control variables and conditional mean independence. What is it? Well, we can look at one example, and we have the following model. The birth weight is explained by the variation in cigarettes smoked per day by the pregnant woman, and family income, the mother's education, and the father's education. And this is our population regression. We might have some omitted variables here, like diet, but let's disregard that and look at the variable of interest here, which is the how cigarettes, the number of cigarettes smoked during pregnancy, affects the birth weight of the child. So the beta 1 is our coefficient of interest, and the other coefficients, the other variables, family income, mother education, and father education, they are just there to reduce the omitted variable bias, because they might be correlated with our variable cigarettes, and they might have an effect which is a non zero slope in relation to the birth weight variable. So we include these control variables in the study to reduce the omitted variable bias. And remember that we have the first least squares assumption in the multiple regression model. It's that the conditional expectation, given the values of the x variables, should be 0. What does this mean? It means that if you have the regression line, then the residuals should be centered around this line, right? So the expectation, no matter which x variable you look at and change its value, then on average you should be in the middle of the data. Okay, and if this holds, then you get unbiased coefficients for the intercept and the slopes. But we only care about one of the slopes, the slope for cigarettes. Then we can actually relax this assumption and only require a conditional mean independence. So what's the conditional mean independence? It's for our example, we want to figure out the effect of cigarettes on birth weight. So look at this. The expected residuals, the mean of the residuals, given the values, any value on these x variables, right? It's not required to be 0, right? What we have to require is that the expected level of the residual, given all the or conditioned on the level of all the x variables, should be equal to the expected level of the residual, given the values of, or conditioned on the values of the control variables. Okay, so this is a weaker condition than the previous condition where this had to be 0. So if this holds, well, if this holds, then we know that the correlation between the residual and the well, I should have it down here. Then we know that the correlation between the residual and our variable, the cigarettes, then this should be 0. Okay, so and this will actually give us a unbiased estimate of the beta hat. So or more precise, but our beta 1 hat will then be an unbiased estimate of the true beta 1. Okay, unbiased. We can write that actually. Will be unbiased. Yeah, I think we have it here. So if you control for family income, mother education, and father education, then the error term and the cigarette variable is uncorrelated, and it will actually enable us to treat the variable cigarettes as randomly assigned. So this will give us the causal interpretation of the effect of cigarette smoking on birth weight. Okay, so it is as if we are performing a random experiment, giving people cigarettes randomly and looking at the birth weight. However, this condition does not say anything about whether or not the other slopes are unbiased. So quite important, read section 7.5 in the book, model specification for multiple regression, because it will help you to decide what kind of variables you want to include in your multiple regression. Okay, see you next time.